So welcome students. In this question, you're asked to find the differential equation corresponding to this solution. So you can very clearly see that you have one arbitrary constant. So if you eliminate this arbitrary constant, you get the differential equation. And you're allowed to differentiate once, right? Because the number of arbitrary constants is the number of times you need to differentiate. So first let us differentiate this equation. So 2x plus 2y dy by dx minus 2a times dy by dx is equal to 0. So this implies if I cancel this 2 out, x plus y minus a times dy by dx is equal to 0. So y minus a times dy by dx is equal to y minus a times dy by dx is equal to minus x. This implies y minus a is equal to minus x dx by dy, hence a is equal to y plus x dx by dy. A is equal to y plus x dx by dy. So I just need to put this a in my original differential equation. So x square plus y square minus 2a, that is minus 2y. Minus 2y times a is y plus x dx by dy is equal to 0. This implies x square plus y square minus 2y square is minus y square minus 2xy dx by dy is equal to 0. So this implies x square minus y square is equal to 2xy dx by dy is the required differential equation. So if you want the differential equation in terms of dy by dx, you just need to do this. Dy by dx times x square minus y square is equal to 2xy. Dx by dy, if it comes onto this side, becomes dy by dx. So you can take whatever form you want and get the answer. Thank you.